So now let's talk about functions of several variables. So we're going to start by talking about partial derivatives. And we're going to look at some examples now. Find all first partial derivatives. So the first one, the function we're going to look at is f of x, y, z will be 3x squared y minus 5xyz plus 10yz squared. So this is just a polynomial, so it's not too bad to find your partial derivatives, fx. So you would get 6x. Remember that your only variable is x right now. So 6xy minus 5yz. And then there's no x in that second term, so it's a constant. Its derivative is 0. Fy. So 3x squared minus 5xz plus 10z squared. And finally, fz. There's no z in that first term, so the derivative is 0 minus 5xy plus 20yz. So these are all my first order partial derivatives. Let's look at another example. Let's say our function is sine of x plus 2y plus 3z. So here we have to use the chain rule. So the derivative of the outside, the derivative of sine is cosine, and leave the inside alone. And then you're going to multiply by the derivative of the inside with respect to x. Well, the derivative of x is 1, and then there's no x in the other two terms, so I'm just getting 1 here for the derivative, partial derivative. And then you repeat this process, but now do it for the partial derivative with respect to y, cosine, and then the derivative of the inside with respect to y now would be 2, and then fz, the derivative of the inside with respect to z would be 3. So here are all my first order partial derivatives. All right, so let's talk about differentials now. So our total differential, if z is equal to f of xy, then our total differential is dz, which is going to be f partial derivative with respect to x dx plus the partial derivative with respect to y dy. So let's look at an example here. Find the total differential for z equals x squared sine y minus 4x squared y. So here you're going to take the partial of z with respect to x. You'll get 2x sine y minus 8xy. And the partial of z with respect to y will be x squared cosine y minus 4x squared. So then your total differential dz would be 2x sine y minus 8xy all times dx plus x squared cosine y minus 4x squared dy. And there would be my total differential. All right, so next we're going to talk about the chain rules. And I'm not going to go into all the different variations. We're just going to look at, let's say, w is f of xy, and then x is a function of t, and y is also a function of t. Well, then w is really a function of t, so then dw dt would be the partial of w with respect to x times dx dt plus the partial of w with respect to y times dy dt. So let's look at an example here. Find dw dt given w is x squared y minus y squared, x is cosine t, y is e to the t, and I want you to find, so I'll add in something here, find dw dt when t is equal to pi. So first we're going to find dw dt using the chain rule. So you're going to take the partial, so I'll write down the formula again, plus the partial of w with respect to y dy dt. So we're going to take the derivative with respect to x, so you'll get 2xy, and then times the derivative of x with respect to t minus sine t, the partial derivative of w with respect to y, so it'll be x squared minus 2y, and then the derivative with respect of y with respect to t is e to the t. Now we want to find dw dt when t is pi. So you probably should find what x and y correspond to. What are their values when t is pi? So if t is pi, cosine of pi is -1, y equals e to the pi. And so now, when we said t is pi, we're going to plug in all of this into our derivative. So dw dt will be 2 times -1 e to the pi minus sine of pi plus -1 squared is 1 minus 2 e to the pi times e to the pi. So here we're going to get positive 2e to the pi. Sine of pi is 0. So I'm just really getting 1 minus 2 e to the pi times e to the pi. There's my answer. All right, so we're going to continue talking about functions of several variables in our next video.